Hey guys, tonight we begin with a question as old as curiosity itself, a question that rests quietly in the back of every wondering mind. Is there a multiverse? And if there is, could another version of you exist somewhere out there, living a life just slightly different from this one? Perhaps in another reality, you're watching the same video at the same moment, but your thoughts drift in a slightly different direction. Perhaps you never found this channel at all, or perhaps you're the one who made it. Welcome to the Midnight Narrator. Tonight we'll move slowly, gently, and with curiosity, exploring what scientists, philosophers, and poets have wondered about for centuries. We'll glide from the known edges of the cosmos to the soft, strange edges of possibility. Along the way, we'll pause, breathe, and let images unfold. Images that invite sleep rather than alarm. Tonight's journey will touch on many ideas. What we mean by our universe, how far we can actually see, the strange notion of horizons we cannot cross. The earliest myths of many worlds, the physics that suggests other universes might exist, and the personal, philosophical questions that follow, like whether another version of you could be out there, living a life both eerily similar and quietly different. If you allow me the privilege of your attention, I'll walk you through each of those places in a calm, clear way. I'll offer stories and simple science, gentle metaphors and small teasers of what comes next, all intended to keep you peacefully curious until the very end. Before we settle in and begin our peaceful journey, take a moment to like this video and subscribe, only if what I share here truly resonates with you. Your support helps me create more of these videos, and if you feel like it, let me know where you're tuning in from and what time it is. It's always fascinating to see the many corners of the world where we connect. Now, dim the lights, make yourself comfortable, and let's ease into tonight's journey together as we explore what lies ahead. Chapter 1. The Edges of the Known Universe. Imagine standing on a quiet shore at dusk. The sea stretches away in a thick, dark band. The far edge of your sight is a soft line where water becomes sky, a horizon that suggests there is more, but that more lies out of reach. The universe has a similar kind of horizon. In this chapter, we'll walk along that shore, listening to the vast, gentle hush of the cosmos and asking, calmly and plainly, what we mean when we say, our universe. When most people say universe, they mean everything we can, in principle, measure and study. The galaxies, stars, planets, dust, light, and the physical laws, gravity, electromagnetism, quantum rules, that shape their behavior. It is the enormous set of things and interactions that make up the reality we inhabit and observe. But even this clear-sounding phrase holds a subtlety. Our universe can mean the part of reality that is causally connected to us, everything that has affected us or could affect us, rather than a metaphysical absolute that must include everything that might possibly exist. If you close your eyes and imagine all the light that has ever reached you, what you hold is the observable universe. Because light takes time to travel, looking far into space is also looking back in time. The galaxies we see at the edge of our view are not where they are now. They are where they were when their light left them long ago. Physicists describe the observable universe as a sphere centered on us, not because anything makes Earth special, but because every observer has their own observable sphere. From our vantage, that sphere extends tens of billions of light years in every direction, a gently curved surface of distant light and ancient history. To picture the observable universe in a soothing way, imagine a lantern in a dark hall. The lantern's glow reveals nearby objects easily, the grain of a wooden chair, the edge of a table. Farther away, the light dims, revealing only faint shapes and shadows. The observable universe is like the glow of that lantern, a warm circle of knowledge reaching outward, beyond which everything is dim and unknown. Beyond the observable sphere lies a question that is as inviting as it is quiet. Does more continue beyond that horizon? There are several ways to imagine what lies there. One simple possibility is that the fabric of space continues much like it does nearby. More galaxies, more stars, simply beyond our reach. Another possibility is stranger, regions where the physical conditions are different, where the shapes of matter and the constants of physics take other values. The important, gentle truth is that the horizon is not a hard wall. It is a limit set by the speed of light in the age of the cosmos. It separates what we can know from what may be forever hidden. The limits of human perception and the question that starts it all. Is this all there is? Humans have a particular way of knowing. We learn from light, from particles, from signals that arrive at our instruments. But nature may contain information that never reaches us because it lies beyond causal contact. Imagine whispers in a different room, doors closed, sound unable to travel. We can wonder about that closed room, we can imagine its wallpaper and furniture, but we cannot hear its whispers. Similarly, the cosmic horizon keeps some information forever out of reach, and that limit is what fuels the deepest of our questions. Is what we see the whole story? There is an old story of a traveller walking along a coast at night who comes upon a lighthouse. The light sweeps a broad arc, revealing ships close by and a narrow strip of shoreline. The traveller stands and watches the light, then asks the lighthouse keeper softly, "Do I see all the sea from here?" The keeper responds with a slow, kind smile. "From this light, you see what this light touches. Beyond that, the sea goes on, and beyond that there may be currents and coasts and islands you cannot imagine. But the dark is not empty. It may be full of things you will meet only when another light reaches them. This story is quiet and simple, and it mirrors our cosmic situation. We have a powerful light, mathematics, telescopes, experiments, that reveals much. Yet even as we explore, we must accept that our light has limits. That is not a failure. It is an invitation. It is an invitation to imagine gently, to hypothesize carefully, and to cherish what we can know while holding a tender curiosity for what we cannot. As we linger near this shoreline, it is natural to feel both wonder and a little calm unrest. In the next chapter, we'll step back in time and across cultures, meeting the people who first imagined many worlds, from ancient poets to early philosophers, and see how their stories shape the questions scientists ask today. Knowing where our scientific lantern started helps us understand how it grew bright enough to reveal the cosmic microwave whisper, the smoothness of the sky, and the ideas about many bubble universes. If you're comfortable, let your breathing slow just a touch, and keep a soft curiosity with you. Later chapters will open new windows, each a gentle frame of thought that builds on what we learn here. A few small, soothing reminders to keep you with me. There will be vivid images ahead, but always described slowly, so they invite sleep rather than push alertness. Each chapter will end with a small, satisfying close to help your mind relax and prepare for the next idea. At times, I will weave in quiet metaphors and brief stories, because stories are a gentle way of holding large ideas. Chapter 2: A Brief History of Cosmic Imagination. Imagine a night long ago before electric lights, when people sat beneath the same slow sky and watched the same stars. They told stories to make sense of the dark. Those stories were gentle maps for the mind. They helped people find comfort in the unknown. As we move from the edge of what we can see to the ideas that grew in human minds, let us walk softly through those stories. Let us listen to the ways people have imagined many worlds. Long before science had tools and equations, people used stories, songs and images to hold the sky. In ancient times, many cultures did not think of the world as a single solid thing. They pictured layers, rings, or paths that connected different realms. Some thought the sky was a bowl over the land. Others imagined that below the earth there were hidden places where spirits lived, and above the stars there were lands of light. These images were comforting. They made the unknown feel close, like a neighbour behind a curtain. In India, old texts tell of many worlds stacked like pages in a book. These worlds had different ages, different cycles, and different rules. Sometimes the cycles repeated, sometimes new worlds were born and old ones passed away. The idea was not that the worlds were strange for trickery, but that life was part of a vast living pattern. In those stories, the self moved through many forms across many lives. The idea of many realms was part of how people understood meaning, change, and time. Buddhist teachings also spoke of many realms. These were places of calm, places of challenge, and places of learning. They were not always far-off lands to visit. Sometimes they were states of mind. In that gentle way, people learned to think of many conditions of being, not just many places in space. That thought is close to what later thinkers would call different branches of reality. It asks a soft question. What does it mean to exist in one form rather than another? In ancient Greece, some thinkers used simple, clear ideas to ask big questions. The atomists, for example, imagined that everything was made of tiny bits, small, hard parts that move in empty space. If the world is made of many little bits, they said, then many arrangements of those bits are possible. That tiny, steady thought later fed into new ways of thinking about many worlds. The atomists did not have telescopes or modern labs, but they had a powerful idea. The same simple parts can make many kinds of things. Across the sea, other myths took shape. Some cultures pictured the world as carried on the back of a turtle. Others imagined a tree whose roots and branches touched many places. These images remind us that people everywhere reach for the same quiet solution. When the world seems too big to hold, make it part of a larger pattern. Many worlds fit that gentle pattern. They let people place their lives inside a grander map. As centuries passed, the maps of the mind changed. The slow light of observation arrived. People learned to measure, to keep time, and to record what they saw. Astronomers watched the motion of planets, the dim paths of comets, and the steady pulse of the moon. When careful observation met thoughtful imagination, new ideas grew. The old myths did not vanish. They mixed with new ways of asking questions. Instead of only imagining many worlds for moral lessons or spiritual growth, thinkers began to ask whether there might be other physical places like ours that follow their own rules. A small story from a night in Alexandria helps us feel this shift. There was once a quiet library city where scholars read by oil lamp. In its halls, a thinker sat and turned pages that described stars and strange ideas. He wondered whether the cosmos might be much larger than people imagined. He thought that what the eye could see might be just the beginning. That thought was simple and brave. It is the kind of thought that echoes through time. Maybe what we call the world is only part of a larger whole. In medieval times, people often mixed the old stories with fresh observations. Monks and scholars mapped the heavens with patient watchfulness. Their work was careful and slow, like the opening of a flower. They counted stars and charted the paths of planets. Little by little, the idea of a finite single world grew into the idea of a vast and varied cosmos. The sky was no longer a dome over a small land, It became a place of depth and distance. When the telescope came into use, many minds felt a gentle shock. Now the eye could see farther. Tiny points of light revealed themselves as distant suns, many with their own small companions. With this new sight, the comfort of the familiar grew strange. If other suns existed, might other worlds circle them? This question moved quietly from myth into the first ripples of scientific thought. People began to think of the universe not as one garden, but as many gardens, each with its own weather and history. By the time modern science took shape, the language of possibility had changed. Theories about how the universe began and how it behaves started to use precise terms and equations. Still, the human urge to imagine many worlds remained. It simply found a new form. Instead of tales of spirits or layered heavens, scientists used ideas about space, time, and the tiny building blocks of matter. Those ideas were not shorn of wonder. They carried it in a different voice, the voice of curiosity that likes to test what it imagines. Even so, the ancient images are not lost. When physicists speak of multiple universes, they sometimes use words that sound like old myths: bubbles, branches, layers. The images are familiar because they answer the same quiet need: to hold the vast in a way the mind can touch. In a gentle way, this is evidence of how close human thought remains to those early stories. We still want a map. We still like a pattern. We still want to know our place. Another small, soft story. There was once an old weaver who made a blanket from many pieces of cloth. Each piece had a different colour and pattern. When the blanket was finished, the weaver would look at it and say, "Each patch tells a little tale. Together they keep us warm in a similar way. The many worlds imagined by ancient people and the many worlds proposed by modern thinkers together keep us warm with meaning." The old stories add depth to modern ideas. The new ideas give old stories a crisp, open form. Both fit together like patches on a gentle quilt. As we listen to this patchwork of human thought, notice how curiosity has a calm rhythm. At first, people gave the unknown a face: gods, spirits, many realms. Later, careful observation peeled back layers, revealing distance, motion, and the slow passage of time. Then, new tools deepened our reach further. Through it all, the question stayed the same: what else is there? That simple question has guided hands and minds across cultures and ages. Before we move on, let us take a breath and a soft promise. In the chapters ahead, we will meet the Big Bang, that quiet beginning that set everything moving. We will listen to the first faint whisper of light and to the ideas that suggest new universes may bubble up, or that quantum choices may split the road of reality. But none of those later ideas began in a vacuum. They grew from the same human desire to know what lies beyond the candlelight. Let your mind rest on that desire. It is patient and kind. It does not demand sudden answers. It asks gently and lets the answers come in time. As we end this chapter, keep with you a small, calm image. People by a fire, turning pages of the sky, sharing stories that make the dark feel near and known. That human habit of telling stories and asking quietly about what lies beyond is the very foundation of the long path we now follow into science. It is the soft root from which our modern search for other universes has grown. Chapter 3: The Big Bang and the Birth of Everything. Tonight we begin with a thought so simple it almost feels like a whisper. Everything we see, everything we are, began from a state that was once unimaginably small, hot, and dense. In this chapter, we will move slowly through that beginning. We will speak softly about how the universe grew from a tiny seed into the vast, cool expanse we drift through now. Picture this as a gentle story of growth, like bread rising in a warm oven or a quiet pond turning to a wide lake over countless seasons. At the very start, there was not a bang in the way a rock hits water. It was not an explosion that sent debris flying into empty space. Instead, it was space itself stretching and cooling. Imagine a small, smooth ball of soft dough. Inside that dough, everything is mixed together. Heat, energy, and potential. As the dough warms and rises, it stretches and changes shape. Tiny features appear, little pockets, soft folds. The Big Bang describes a time when space, time, and the energy inside them began to grow and shift. That growth is the heart of the story. In those first moments, everything was very hot. The heat was so intense that matter as we know it could not hold together. Particles and light danced together in a bright, searing sea. There were no atoms yet, no stable structures. Instead, there were fundamental bits, simple pieces of matter and energy that zipped and spun in a boiling stew. As this stew expanded, it began to cool. Cooling allowed new things to form. Much like steam condensing into drops on a cool window, the energy slowly rearranged into the first particles that would later build atoms and farther on stars and planets. A calm way to think about time in this story is to imagine a long, slow melody. At the first notes, the sound is rich and pure. Then different instruments join, one by one, each adding colour. In the universe's melody, the first instruments were the tiny particles, quarks and electrons, forming and mingling. After some time, the quarks combined into protons and neutrons. These were the sturdy pieces that would later become the centres of atoms. As the universe cooled further, protons and neutrons could stick together to form simple nuclei, like the cores of hydrogen and helium. This stage is gentle to imagine, a delicate knitting where a few threads join to make simple loops. And yet these early loops mattered. They set the stage for everything that would come later. The mix of hydrogen and helium left over from that era became the raw material for stars, galaxies, and eventually for planets like our own. One of the most peaceful and beautiful fingerprints from this ancient era is a faint glow that fills the universe even now. It is a whisper of light left over from when the universe first cooled enough for atoms to form and for light to travel freely. Before that moment, light could not travel far. It scattered like sunlight through fog. But when neutral atoms formed, the fog cleared and light began to move unimpeded. Over billions of years, that light has stretched and cooled along with the expanding universe, arriving to us as a soft, steady glow in every direction. Imagine standing on a quiet beach at dawn, watching the sky gently brighten. That glow is a kind of dawn from the universe's own childhood. That early light also carries patterns, small ripples of temperature and density that look like tiny hills and valleys. Those ripples matter because they seeded the structure we see today. In the vast quiet between galaxies, these tiny differences in density let gravity gather matter together slowly, gently pulling gas into knots that later became the first stars and galaxies. Think of a field of frost where some spots are just a little thicker. As the sun rises, those spots catch warmth differently and the pattern changes. In cosmic terms, those initial variations grew into the scaffold of the universe. The stars formed from collapsing clouds of hydrogen and helium. They lit the darkness and produced heavier elements inside their glowing cores. When those stars burned out, they scattered those elements into space like soft snowfall. Over long ages, the scattered dust collected into new stars and planets, and some of that material found its way into the chemistry of life. In this way, the story of the Big Bang is also the story of how the rawest materials became the rich diversity that makes our world possible. The atoms in your body were forged in the hearts of ancient stars, a quiet, beautiful connection that binds us to the distant past. There is a natural rhythm to these events. heating and cooling, clumping and spreading, light and shadow. That rhythm unfolds over enormous stretches of time, far beyond a single human life, and yet it leads gently toward the familiar shapes we know: stars, galaxies, planets, life. The large story is patient and wise. It does not rush. It takes the quiet time needed to make complexity from simplicity. Now, a soft question arises as we listen to this slow tale. If the universe began this way once, could such a beginning happen again? Could another universe bloom from its own tiny seed, with its own pace, its own tune? That question is a tender seed for the chapters to come. Some ideas suggest that what we call the Big Bang could be one of many births. Other ideas imagine that the conditions that made our universe are unique. We will look into those ideas carefully and calmly. We will not demand answers. Instead, we will trace the gentle logic that leads scientists to ask why and how the first moment happened. A small story to hold as we move onward. There is an old gardener who plants a seed and tends it each day with water and patience. Seasons pass. The seed becomes a sapling, then a full tree bearing fruit and shade. When the gardener walks in the garden, she sometimes wonders if another seed in another field is following a similar path. She cannot see that other seed, but the thought comforts her. Maybe elsewhere, in a far-off place, a tree also grows. We feel a similar comfort when we imagine other beginnings. The universe that rose from its tiny seed grew into beauty and complexity. Thinking that other seeds might bud somewhere else is not a claim of certainty. It is a gentle, hopeful extension of the story we have just begun to tell. As we finish this chapter, remember the soft images: a hot, dense seed that slowly cools, light clearing the fog to reveal a newborn dawn, ripples that become stars. These are simple, calm pictures meant to help your mind rest and imagine rather than jump to sharp conclusions. In the next chapter, we will listen to a remarkable idea that changed how many scientists think about beginnings, a period of extremely rapid growth, where space itself ballooned out in an instant. That idea helps explain why the universe looks so smooth and why those tiny ripples exist in the first place. It is called inflation, and we will meet it slowly, like a gentle wind that stretches a small sail into wide cloth. Before that gentle wind arrives, let your breathing slow if it has not already. Let your thoughts drift like slow clouds above a wide plain. There is no need to hurry. The universe grew patient, and so can we. Tonight we travel through time not as a sprint but as a long, warm walk. Let curiosity and calm keep you company. Chapter 4: Cosmic Inflation, the theory that changed everything. Imagine, for a moment, a tiny balloon in a child's hand. The balloon is small, warm and plain. Then, with a sudden breath, it grows and grows so quickly that the tiny specks on its surface fly far apart and the surface smooths out. That simple image holds the heart of a quiet, powerful idea called inflation. In the last chapter, we felt the universe unfold from a hot, dense seed into a cooling, growing space. Tonight, in this chapter, we will slow down and listen to a very specific moment in that growth. A moment so extreme that it helps explain why the sky looks calm and why the universe holds the soft patterns we observe today. Scientists noticed a few calm puzzles about the universe. The sky looked almost the same in every direction. Distant regions that could never have touched seemed to share the same temperature, like two rooms that somehow agreed on the same thermostat setting. Also, space seemed to be laid out in a way that felt almost perfectly flat, not curved like the surface of a balloon or the belly of a bowl. These were quiet mysteries. They did not shout for attention, but they asked for an explanation. To answer them, a few scientists in the late 20th century offered a gentle but bold idea. Perhaps early on the universe grew hugely for a very brief time, stretching itself so quickly that tiny irregularities were smoothed out and small quantum ripples were blown up into gentle hills and valleys on a cosmic scale. Alan Guth was one of the first to describe this idea in a clear way. Picture that small balloon again, only now imagine its surface contains tiny wrinkles and seeds. If the balloon inflates very rapidly, those wrinkles are pulled flat and the seeds are flung far apart. In the cosmic story, inflation is a sudden stretching of space itself. It is not that things inside space moved quickly in ordinary motion, rather, the fabric of space grew. In that rapid growth, parts of the universe that had been close became far away in an instant. This can explain why the sky looks so uniform. What are now widely separated regions were once neighbours and could share the same conditions before inflation stretched them apart. Another gentle image helps here. Think of a sheet of dough with small raisins kneaded into it. When the baker rolls the dough, the raisins move farther from each other, but they still belong to the same dough. If that rolling happens quickly and smoothly, the dough's surface appears even and flat. Inflation acts like that rolling, taking a tiny uneven beginning and making it look remarkably smooth and flat at large scales. But inflation did more than smooth, it also planted structure. In the small, newborn universe, quantum physics means there are always tiny wiggles, little fluctuations that are part of the nature of things. Normally these are so small they barely matter. Yet if space grows enormously in a very short time, those tiny wiggles get stretched to huge sizes. Once inflation ends and expansion slows, gravity can take hold of those stretched wiggles, pulling matter into slightly denser regions and leaving slightly emptier ones. Over long ages, these differences grew into the web of galaxies and clusters that paint the night sky. In other words, the very seeds of stars and galaxies may have begun as whispers of chance, made visible by the sudden stretching of inflation. A soft, thought-provoking twist came from further work on the idea. Inflation might not be a one-time neat event. Some versions of the theory suggest that inflation is eternal, meaning it keeps happening in pockets of space in different ways. Picture a pan of boiling water where bubbles form, rise, and pop. In an eternally inflating cosmos, regions of space keep producing new pocket universes, each one cooling and settling into its own pattern, while the overall background keeps inflating. Our own universe would be one of those cozy pockets, a calm bubble in a larger restless sea. This imagery gives rise to a tender sense of scale and humility. If inflation continually buds off new regions, then what we call the universe might be only one small, calm corner in a vast and varied collection. Each pocket could have its own properties, different amounts of matter, different physical constants, even different ways atoms behave. Some pockets might be barren and quiet, others might bloom with complexity. This vision shifts our view from thinking of the universe as a unique stage to seeing it as a single theatre seat within a sprawling auditorium of theatres. Of course, the idea of eternal inflation raises soft but real questions. If new regions are being formed all the time, how could we ever know about them? Many of these other pockets would be forever out of reach, separated by space that stretches faster than any signal could travel. That's why inflation is both helpful and humbling. It explains things we can see, but it also suggests there is more than we can ever touch. This delicate balance is part of what makes the idea so hauntingly beautiful. There is another gentle point to hold. Inflation provides testable predictions. The stretching of quantum ripples should leave a specific pattern in the faint afterglow of the early universe, the soft light that fills the cosmos from its youth. The patterns we observe today match the expectations of a universe smoothed and seeded by inflation, which is why many scientists find the idea convincing. Yet, as with all deep ideas, the story is not closed. There are many versions of inflation, and each version gives slightly different details about how the buds and bubbles form. Some of those versions lead naturally to the image of a multiverse, a vast foam of bubbles, while others remain more modest. To keep this gentle night journey grounded in human terms, imagine a creek that runs through a wide plain. Sometimes new pools form where the creek slows and deposits silt. Each pool becomes its own little world for fish and plants. In the same way, inflation can create many pools of space, each one a small habitat with its own conditions. We cannot visit those pools easily. Many are downstream, far away, beyond sight. But imagining them gives us a new sense of how large and creative reality might be. As you rest with this thought, notice how inflation stitches together two sorts of wonder: the simplicity of small beginnings and the complexity of what grows from them. It takes tiny quantum seeds and makes them into the structures we know. It smooths the sky while giving it rich patterns, and in some versions, it gives rise to a gentle, endless garden of universes, each with its own quiet life. Before we move on, take a slow breath and let a small promise settle. In the next chapter, we will trace how the idea of a multiverse moved from early speculation to a serious topic in modern cosmology. We will meet the thinkers who shaped that move and the quiet debates that followed. For now, hold the image of the balloon and the bubble, of tiny ripples made large, and of a cosmos that might be far stranger and more generous than our first glance suggests. Chapter 5: The Birth of the Multiverse. Hypothesis. There comes a quiet moment in the life of an idea when people stop treating it like a passing fancy and begin to take it seriously. That is the moment when questions are asked in a new way, when careful math meets patient observation, and when old hesitation makes room for cautious curiosity. In this chapter, we will move gently through that shift. How the thought of many universes walked out of myth and speculation and stepped into the measured light of modern cosmology. For a long time, the idea of multiple worlds was treated as philosophical or poetic rather than scientific. Many scientists were rightly cautious. Science grows by testing ideas against what we can measure. If an idea could not, even in principle, be tested, then it seemed more like a story than a scientific claim. So the early reaction was soft skepticism. Some researchers said, calmly, "It is a beautiful picture, but we cannot prove it. Let us first study what we can touch and measure." That careful refusal was not closed-mindedness. It was a commitment to method. It kept science rooted in evidence. Yet some parts of physics gently pushed back against that neat line between myth and science. As inflation took shape and physicists explored its math, new possibilities began to appear. One of the key voices in this change was a thinker named Andre Linde. He introduced what came to be called chaotic inflation. The name sounds wild for our calm journey, but the idea itself is simple to picture. Imagine a landscape of hills and valleys made of soft clay. In some valleys, conditions allow a small patch to settle and cool into a stable shape. In other places, the clay keeps bubbling and forming new patches. Linde's idea suggested that inflation could behave like that. Some regions stop inflating and form universes like ours, while other regions keep inflating and create more pockets. Over time, a vast and varied collection of pocket universes could emerge. This was a gentle but profound shift. It moved the multiverse from poetic metaphor into a framework that could be studied with equations. Suddenly, it was not just an imaginative image. It was a natural outcome of a theory that had already explained key things about our own cosmos. If the math that described inflation also allowed many pockets to form, then the idea of a multiverse became a natural if surprising consequence. Around the same time, other branches of physics were growing that seemed to support the same kind of picture. String theory offered a new way to think about the fundamental building blocks of reality. Instead of point-like particles, string theory imagined tiny vibrating threads, whose modes of vibration give rise to different particles. The theory requires extra dimensions tucked away in small folded shapes. Those shapes can be arranged in many different ways. Each arrangement would change the way particles behave and the values of the physical constants. Taken together, these many possible arrangements formed what some called a landscape of possible laws, a soft field of alternatives, each producing its own kind of universe if realized. When the picture from inflation and the picture from string theory were placed side by side, a more complete vision began to emerge. Inflation could create many pockets of space, and the string landscape could provide each pocket with different physical rules. This combination suggested a universe that was not uniform by necessity, but varied by consequence. It was as if a single painter used many small brushes to make a large canvas full of distinct patches, each with its own shade. That idea naturally raised many questions, and the scientific community responded with curious seriousness. How could we tell if other pockets existed? What would it mean for our methods if some things about reality were forever beyond our reach? Could the multiverse idea be tested in any meaningful way? Or would it remain a metaphysical notion? These questions pushed researchers to think carefully about what counts as evidence and how to interpret our observations. One of the more delicate concepts that rose in this discussion is called the anthropic idea. It is a soft, reflective thought. Among many possible universes with different rules, life, as we know it, can only arise in certain kind of places. If the physical constants were wildly different, stars might not form, or chemistry might never produce the building blocks of life. So the fact that we find ourselves in a universe that supports life may not be surprising if many other kinds of universes exist. This line of thought does not offer hard proof of other universes, but it does suggest a way to reason about why our universe has the gentle balance it does. For some scientists, this is a useful clue. For others, it is an uncomfortable direction because it can feel like explaining things by selection rather than mechanism. The debate is calm but lively, and it has helped refine what we mean by explanation in science. As the idea became more discussed, the community developed new ways to test related consequences. Researchers looked for signatures in the faint afterglow of the early universe that might hint at collisions between bubble universes or other telltale marks. They also examined whether the predictions of inflation matched the patterns we measure in the sky. While no clear, direct evidence of other pockets has been found so far, the mathematical framework and observational successes of inflation made the multiverse a topic worthy of serious thought rather than mere daydreaming. A soft example helps here. Think of sailors learning to navigate by stars. At first, they charted the coast and learned how to read wind and tide. Later, when they ventured farther, they began to notice small clues, slight changes in the colour of the water or the fog that hinted at currents or islands beyond sight. Those clues did not prove the existence of distant lands, but they suggested lines of inquiry. In the same way, subtle matches between theory and observation can serve as hints, guiding us toward larger pictures even when the full map is out of reach. The birth of the multiverse hypothesis also changed how people spoke about cosmology. Some embraced a broader view in which the universe is a single region inside a larger tapestry. Others urged caution, reminding us that science must cling to testable claims. This polite tension has been productive. It has encouraged clearer thinking about what can be known, what might be inferred, and what remains speculative. That distinction matters because it keeps the field honest while allowing room for bold ideas. As we finish this chapter, hold a calm image, a quiet workshop where thinkers fold small pieces of paper into many shapes. Each folded piece is a possible universe, slightly different in form. Some are plain, some patterned, some rich with hidden folds. The workshop hums with quiet attention. The creators test one fold, then another, and slowly learn the language of forms. That is how modern cosmology learned to treat the multiverse, not as a single bold claim, but as a set of ideas to be shaped, tested, and refined. In the next chapter, we will look at a particularly clear way to organize these many ideas. A thinker named Max Tegmark proposed a simple structure that divides the multiverse into levels. That framework helps us see the different kinds of many worlds without mixing them together. It will guide us gently through the forest of options, so we can see how each idea stands on its own. For now, let the thought settle that the multiverse moved from poetry to math, from myth to a question that serious scientists felt they could and should talk about. Chapter 6: The 4 Levels of the Multiverse, Max Tegmark's Model. Tonight, as we continue our slow walk through these vast ideas, let us lay out a gentle map. One clear way to think about the many kinds of multiverse is to divide them into levels. Each level is a different way reality might be larger than the small circle we can see. The map is not meant to be final. It is simply a friendly frame that helps our minds hold several big possibilities at once. We will travel through each level slowly and calmly, noticing what makes it different and what its quiet implications might be. The first level is the easiest to imagine. It says that beyond our horizon, the same kind of space continues. If you picture the observable universe as a small patch on a vast blanket, Level 1 suggests the blanket goes on and on. Far beyond what our telescopes can see, there could be more galaxies, more stars, and perhaps regions that look almost exactly like ours, simply too far away for their light to have reached us yet. In an infinite or very large space, the same patterns can repeat. That repetition becomes almost certain if space truly has no edge. Thinking about this level invites a soft feeling. Our place may be common in the sense that many similar regions exist, though they remain forever out of reach. For the question of another you, Level 1 suggests that far enough away, given enough space, similar arrangements of matter might occur. Perhaps a planet much like Earth, with people much like us. But such places are separated by distances so vast they belong more to imagination than to visit. Level 2 grows a little stranger and a little more colourful. Here the idea of eternal inflation from earlier plays a role. Imagine many bubbles forming in a vast sea. Each bubble can cool and settle into different conditions, like colours and textures that depend on how the bubble formed. In Level 2, each bubble is its own region with possibly different physical rules. The strength of forces, the masses of particles or subtle numbers that shape chemistry might vary from bubble to bubble. The reason is that the processes that set those numbers during early growth can end in different ways. These bubbles are not merely far, they could have different landscapes of possibility. If we lived in a Level 2 universe, the larger space would be a patchwork of many different kinds of physics, and our own laws would be just one local choice among many. Level 2 brings with it a soft kind of humility. If the constants of nature can vary across bubbles, then the fact our universe supports life might be one of many outcomes. That thought shifts some questions from why these laws to, given many laws, which ones allow observers like us? It feels a little like walking into a garden full of many kinds of flowers and recognizing that you stand in a patch that happens to suit your taste. The image is not meant to lessen meaning. Rather, it widens the view and shows how our corner might fit into a far richer variety. Level 3 takes us into the strange and gentle world of quantum mechanics. In our usual experience, choices lead to single results. We flip a coin and it is either heads or tails. But at the smaller scales, nature behaves like a set of probabilities, where outcomes are not fixed until they are measured. One interpretation of this behavior suggests that every possible outcome actually happens, each in its own branching reality. Imagine a tree whose branches split at every small decision point. Each branch carries a slightly different history. In Level 3, these branches are real universes. When an event with multiple possible outcomes occurs, the universe's history forks, and every possible branch continues in its own direction. This view is sometimes called the many worlds idea. It asks us to think of reality not as a single road, but as a vast network of paths where every quantum choice makes a new path. For our question about another you, Level 3 is the closest to the notion that exact copies of you could exist because it allows many versions of events to unfold, some differing by tiny quantum details. In some branches, you might have poured tea instead of coffee this morning. In others, you might have chosen a different route to work. The branches that matter most for our experience are those where differences accumulate into noticeably different lives. The idea is both simple and profound. Possibility itself becomes a kind of reality. Finally, Level 4 moves into a more abstract and gentle speculation. The idea that any consistent mathematical structure corresponds to a real universe. In this view, the ultimate fabric of reality is mathematics, and every coherent mathematical system exists as its own world. This is a broad and bold leap, but thought of softly, it is a way of asking whether existence might be broader than what our physical senses can touch. If math describes a pattern, could that pattern itself be a home for a kind of being? Level 4 says perhaps yes. All consistent patterns get their own quiet place. Each level paints a different picture of what many might mean. Level 1 is more of the same, stretched wide. Level 2 is a gallery of rooms with different decorations. Level 3 is a forest of branching histories. Level 4 is a library of all possible books. The map helps because it keeps distinct the ways one can talk about multiple universes. It prevents the ideas from blurring into a single vague suggestion and allows us to weigh each possibility on its own. As we move gently through these levels, questions arise. Which ones are testable? Which are poetry? Which feel like natural consequences of theories we already use? Some of the levels are closer to what our instruments can touch. For example, Level 1 and parts of Level 2 follow naturally from ideas that already explain aspects of the sky we see. Level 3 grows from the structure of quantum physics itself. Level 4 is the most abstract and for many the most poetic. Each level also carries different consequences for the idea of another you. In Level 1, copies are distant repeats. In Level 2, copies may be rare or impossible if the local laws differ too much. In Level 3, many versions of you arise from quantum branching. In Level 4, you can correspond to any coherent mathematical pattern that represents similar structure. There is a practical challenge that quietly follows these thoughts. How do we decide which level, if any, matches reality? Scientists look for indirect clues. They test the predictions of the theories that lead to these models. If inflation predicts certain patterns and we observe them, that strengthens the parts of Level 2 suggested by inflation. If the quantum formalism continues to work without adding special collapses, that lends credence to Level 3's branching view. yet some parts will remain beyond reach, like distant rooms behind locked doors. That is why clear thinking about what counts as evidence matters. The map helps keep our hopes and doubts in balance. Let us imagine two small stories to hold these differences softly. The first story is of a vast plain dotted with lanterns. Each lantern lights its own patch. Some lanterns glow with similar light, others burn in different hues. Walking across the plain, you might only ever see the few lights nearby, but you know the landscape extends. That picture is like level 1 and 2, a large field with varied patches. The second story is of a river that splits over and over into many streams. Each stream carries a slightly different pattern of leaves and stones. Standing on the bank, you can follow one stream and imagine how the others might look. That is like level 3, branching histories. Finally, imagine a library where each book is a self-contained story, written in its own style. Each book is complete in itself, regardless of the others. That library whispers of level 4, a collection of patterns, each a quiet whole. As we end this chapter, keep with you the gentle reassurance that thinking about these levels is not meant to unsettle, but to broaden. Each level is a way to place our small story within a larger frame. Whether the true nature of reality corresponds to one of these levels or rises from something we have not yet imagined, the exercise of mapping the possibilities helps our minds practice holding wide things with calm attention. In the next chapter, we will step into level 3 more carefully. We will slow down to listen to the quantum world, the famous thought experiments, and the idea that every choice might split reality into many paths. We will ask what that might mean for choice, identity, and the quiet thought that somewhere, another you might be living a different life. For now, breathe slowly and let the image of the lantern plain, the branching river and the silent library settle like a soft quilt around your shoulders. Chapter 7: Quantum Realities and the Many Worlds Interpretation. Tonight, we walk very close to the smallest things we know, the tiny bits that make up atoms, light, and the world under your fingertips. The quantum world behaves in ways that can feel strange, but if we move slowly and breathe while we listen, its strangeness becomes a soft, intriguing pattern rather than a sharp shock. In this chapter, we will meet the simple experiments and the calm ideas that led some thinkers to propose that every possible outcome of a quantum event actually happens, each in its own quiet branch of reality. We will speak about what that might mean for choice, for identity, and for the gentle notion that another version of you could exist somewhere in those branches. At the heart of quantum mechanics is a gentle rule: until we look or measure, certain properties of tiny things are not fixed. Instead, they are described by a list of possibilities with weights that tell us how likely each one is. Imagine a small boat on a still pond that might drift to the left or to the right when a breeze starts. Until the breeze arrives, the boat's path is not set. Quantum objects are like that boat. Before a measurement, they are in a fuzzy mix of possibilities. When we measure, the world seems to choose one path, and the others vanish from our view. This sudden selection is called the collapse of the wave function in some ways of speaking, but others have a different way to think about it, and that is where the many worlds idea gently enters. To help the idea settle, let us consider a famous thought experiment told simply. Imagine a cat in a quiet box with a simple device that has a 50-50 chance of releasing a small puff of poison. If the device goes off, the cat is harmed. If it does not, the cat is fine. In the usual telling, until we open the box and look, the cat is somehow both safe and not safe. A weird mix that worries our common sense. The thought experiment is not meant to be cruel. It is a way of showing how quantum rules applied to big things look odd. Hugh Everett, a physicist in the 1950s, suggested a calm, radical answer. He proposed that when a quantum choice is made, the universe does not discard the other outcomes. Instead, the universe branches. In one branch, the device went off and the cat is harmed. In another branch, the device did not go off and the cat is safe. Both branches are real, and each continues on its own path. From the point of view inside one branch, things look normal. You open the box and see a single outcome. But the many worlds view says the other outcome also exists in a parallel branch, where equally real observers experience that result. This can sound alarming, but it can also be described in a softer way. Think of a book whose pages describe different versions of a story. Each page is complete and real in the sense that it tells a full story. Turning one page does not destroy the others. You live on one page and remember events that happened on it, but the other pages remain as complete possibilities. In Everett's picture, every time a quantum event with several outcomes happens, the story of the universe spreads into several pages, each representing one choice. Over time, the pages multiply into a very large, branching tree of histories. A useful piece of calm science to hold here is the idea of decoherence. In simple words, decoherence explains why these branches do not tangle back together in ways we notice. When a quantum system interacts with its environment, the air, photons, or other particles, the different possibilities become effectively separate. It is as if the paths of the branching tree grow thick trunks that keep the branches apart. Because of decoherence, branches stop interfering with one another in any way that can affect observers like us. This is why we do not experience strange blends of outcomes in everyday life. The branching happens mostly at scales and conditions where quantum events are significant, and decoherence quickly makes those branches independent. One gentle consequence of this view is that every time there is a choice at the quantum level, a new version of history exists where each option is realized. Over long times, many small differences can grow into larger differences. Maybe in one branch you spilled coffee this morning and missed a meeting that led you to a different day. In another branch you did not spill it, and your day unfolded differently. The differences accumulate like small streams that flow into different rivers. The many worlds idea thus becomes a way to picture how many versions of life might exist across the web of branches. Scientists have tested quantum mechanics with great care, and the rules that predict probabilities match experiments wonderfully well. Many worlds is not a different set of rules for predictions. Rather, it is a different way of interpreting what the rules mean. Some people love this interpretation because it removes special collapses and treats the wave function as a real thing that evolves smoothly. Others are uneasy because it seems to explode reality into countless unseen branches. Both reactions are calm, reasonable, and part of a healthy debate. A quiet strength of the many worlds view is that it treats quantum laws uniformly. There is no mysterious moment when the world decides to collapse, only when someone looks. Instead, observers themselves become part of the branching. When you observe, your own state becomes correlated with the result. In the branch where you see outcome A, you remember seeing A. In the branch where B occurred, you remember B. The idea brings comfort to those who prefer a seamless, unbroken story for physics. Yet many worlds also raises soft philosophical puzzles. If every possible outcome happens, what does it mean to make a choice? Does free will evaporate if all options are realized somewhere? One gentle way to hold this is to separate two questions. First, does the branching picture change the subjective feeling of choosing? Probably not. From inside a branch, you still make decisions and feel responsibility. Second, does the fact that other branches contain versions of you who made different choices reduce the meaning of your life in this branch? Many find that it does not. Even if other versions of you live out different paths, your experiences and the relationships you build here remain real and valuable. The existence of many branches can expand wonder rather than steal significance. Another quiet puzzle is probability. If all outcomes happen, what does it mean to say one outcome is more likely? In many worlds, probabilities relate to the sizes of branches in a precise mathematical way. Some branches carry more weight in the wave function than others, and those weights line up with the usual probabilities we measure. The math is calm and exact, but the feeling can be strange. Probability becomes a statement about the structure of branches rather than a single, unique future. Many thoughtful researchers have worked to show how the common notion of chance emerges naturally in this picture. To make the idea more human, imagine a gardener who plants 1,000 seeds. Some seeds sprout into tall trees, others into small bushes, and some never sprout at all. If we think in branches, each seed's fate is like a branch of history. The gardener lives in one garden and tends it. She does not diminish the other gardens that might exist. She simply cares for the life she sees. In a similar way, many worlds invites us to live with kindness and attention in our branch, while accepting that the larger tapestry may be full of other threads. Critics of many worlds urge caution. They ask whether multiplying realities is a scientific idea or a metaphysical one. They worry it creates too much unseen stuff. Supporters reply that physics sometimes leads us to strange places, and the measure of a good idea is how well it helps predict and explain what we observe. The debate is not a battle. It is a long conversation that keeps the field honest and curious. As we draw this chapter toward a close, imagine again the tree of branches. Each fork is a quiet possibility. Each leaf is a life lived in one pattern of events. If another you exists in a nearby branch, they're not quite the same person as you are here. They share history up to a point, but then backstory diverges like roads. The thought can make us feel both tender and bright. Tender for the many lives that could be, and bright with the knowledge that our choices are part of a larger, intricate weave. In the next chapter, we will step back to consider a different, almost mathematical idea. If space goes on forever, how likely is repetition? Could the same arrangement of atoms repeat somewhere far away, leading to a near-exact duplicate of you? We will move from branching histories to the quiet geometry of the endless space, and consider what that might mean for the idea of cosmic twins. For now, rest with the image of the branching tree and breathe slowly as the branches settle into the night. Chapter 8. Infinite Space. Infinite You. We begin with a gentle image. Imagine standing on a wide, empty plain that stretches farther than your eyes can see. The ground looks the same in every direction, and the horizon never quite comes into view. If you walk and walk, the scene keeps repeating. The same grasses, the same small hills, the same sky. That steady, repeating plain is a quiet way to picture what physicists mean when they talk about infinite space. In this chapter, we will move slowly through the idea that if space goes on forever, then configurations of matter, even whole planets and people, could repeat somewhere far beyond the light we can see. We will walk through what that means, why it might be true, and what it would feel like if it were so. First, let us make clear what we mean by infinite space. The idea is simple to say. There is no edge, no final border, no last star. Space continues indefinitely in every direction. That is a strong idea and not something we can prove by looking, because our view is always limited by the distance light has had time to travel since the universe began. Still, infinity is a neat mathematical possibility, and a natural option in many cosmological models. If space is truly infinite and fairly uniform on the larger scales, then a remarkable consequence follows from simple, comforting logic. Imagine a small region of space the size of the part we can see, a sphere that holds all the galaxies, stars, and cosmic background light we can ever observe. Let us call that a cosmic patch. In that patch, there are only so many ways matter can be arranged. At first, this may sound odd, because matter seems unlimited in its variety, but when you think carefully, especially in the light of quantum rules, possibilities become limited. Quantum physics and simple, physical constraints mean that within any finite volume, there is only a finite number of distinct configurations that are meaningfully different. Put another way, given the smallest meaningful units and the constraints of how particles can arrange themselves, there is a very large but finite set of possible states for a patch the size of our observable universe. Now hold that with a soft breath. If there are only a finite number of distinct patches, and space contains infinitely many such patches, then by simple repetition, every possible patch must appear again and again. It is like having only a finite set of unique postcards, but an endless wall on which to paste them. Eventually the same postcard will recur. In this view, somewhere far beyond the light that has reached us, there could be another patch that is almost exactly like our own, with nearly the same positions of galaxies, stars, and even the arrangement of atoms on Earth. A place could exist where events unfold in ways that mirror our history up to a point. That reasoning leads to a striking possibility. Not only might there be places that look like our solar system, but given enough distance, there could be patches where people very much like us live lives that are almost identical. The distances involved, though, are mind-bending. Even the nearest such repeat, by conservative estimates, would be unimaginably farther than anything we can reach or ever see. It would be so remote that it might as well belong to a different dream. The repetition is a mathematical inevitability only if the space is infinite and the rules inside each patch do not allow truly limitless variation. Those are two important conditions. If space is finite, or if new fundamental possibilities can appear at arbitrary scales, repetition is not guaranteed. A way to hold this calmly is to use a simple analogy. Think about a very long string of random letters. If the string is long enough and the set of letters is limited, then sequences of characters, like a particular sentence or name, will eventually repeat. The longer the string, the more times the sequence might appear. In cosmic terms, letters are like the small quantum states, sentences are like the arrangement of particles in a patch, and the endless string is infinite space. If the string never ends, every possible sentence you can write from that alphabet will appear somewhere. There are warm and strange implications of this idea. If identical patches can exist, then copies of you, not just similar people, but near exact replicas down to memories and choices, might be out there. Yet even if duplicates exist, they are separated by such vast distances that no signal, no message can ever travel between you and them. The light from those regions has not had time to reach us, and the space between you expands too quickly for any contact to be possible. So while the idea is comforting to some and unsettling to others, it does not change the practical fact of your life here and now. You remain local in your experiences and relationships, and the existence of a distant twin does not touch the warmth of your present moment. There are also subtle qualifications that make the picture less absolute. The conclusion that repetitions must occur assumes that physical laws do not allow infinitely fine distinctions in each patch. Some speculative ideas suggest that the number of distinguishable states in a finite region is indeed finite, but others leave open the possibility of infinite variation. If infinite variation were allowed, then exact repetition would no longer be guaranteed. The question melts into nuances about the ultimate nature of space, matter, and quantum rules, questions that humbly remain open. Another consequence worth a quiet breath is how this view reshapes our sense of uniqueness. You might worry that if infinite space makes countless copies of everything, then individuality loses its value. Yet uniqueness does not come solely from patterning alone. It comes from relationships, from context, from the subtle chain of events that link a person to others. Even if someone somewhere goes through a similar sequence of events, your lived experiences, your feelings, and the meaning you make of them retain their depth. It can help to think of repetition not as erasure, but as an echo, a reminder that patterns recur, but each echo still arrives to a single listener in a single time and place. A gentle story to hold this idea. An artist hangs a single painting in a vast gallery with infinite rooms. If the gallery is truly endless, and the artist has only a finite set of paintings, then the same picture will appear in many rooms. A visitor standing in one room sees that painting in a unique light, shaped by the time of day and the company in the room. Even though the artwork repeats, the experience of seeing it at this moment is singular. In the same manner, if cosmic repetition exists, your life is the particular way the pattern plays out here and now. There are also philosophical ripples. Some thinkers point to the idea of Poincaré recurrence, the notion that in a closed finite system, states can, given enough time, repeat. In cosmology, versions of this idea touch on how systems evolve over unimaginable durations. Those considerations can lead to strange possibilities, like the idea of random fluctuations creating brief, self-aware patterns called thought experiments. These ideas are subtle and can be unsettling, but approached gently they can be used to test how comfortable we are with different views of infinity and chance. As we finish this chapter, let us return to a slow, grounding breath. The idea that infinite space could contain infinite copies is both one of the quietest and most mind-stretching notions in cosmology. It rests on a few clear assumptions, and when those assumptions hold, it follows from gentle mathematical logic. Yet it's not something that changes your daily life. It is a vast, distant possibility that invites wonder rather than urgency. In the next chapter, we will turn inward a bit and explore the tiny vibrating threads and extra dimensions imagined by string theory, a different route to thinking about parallel existence. That chapter will guide us through ideas of hidden dimensions and membranes, and ask whether universes could be like parallel sheets in a higher space. For now, let the image of the repeating plane and the single, unique step you stand on settle softly as you breathe. Chapter 9: String Theory and Higher Dimensions. Imagine, for a moment, a violin string being plucked. The note that comes out depends on how the string vibrates, its length, its tension, its thickness. Now imagine that everything in the universe, the particles, the forces, even space itself, is made from many tiny vibrating threads, too small to see. The way each thread vibrates decides what it appears to be, just like different notes come from the same string. This is the gentle heart of string theory, a calm idea that changes how we picture the smallest pieces of reality. String theory began as a simple, beautiful guess. Instead of thinking of particles as tiny hard points, imagine them as slender loops or strands. When these strands vibrate in one way, they behave like an electron, vibrate in another way, and they behave like a quark. The patterns of vibration are like recipes that produce the familiar bits of matter. This shift seems small, but it opens the door to a different picture of the world, one in which space may have more directions than the three we move through. and time may hold surprises we do not yet feel. One of the most striking parts of the idea is that these tiny strings need room to vibrate. In the math of string theory, the equations behave nicely only if space has more dimensions than the three of up-down, left-right, forward-backward that we know. Those extra dimensions are not large like the ones we move through. Instead, they can be curled up so tightly that we never notice them. To imagine that, picture a long garden hose lying in a field. From far away it looks like a simple line. But if you lean in, you see around its circular thickness a small hidden direction that was invisible from a distance. In string theory, the extra dimensions are like the hose's circular path, small, curled, and hidden from ordinary sight. How these extra dimensions are curled up matters a great deal. Different ways of folding or wrapping those hidden directions change the patterns the strings can make. It is similar to how changing the shape of a musical instrument changes the notes it can play. In string theory, the shapes are often imagined as tiny, complex geometries with many folds. Mathematicians describe some of these shapes with names that are careful and precise, but we can think of them simply as different rooms where strings can dance. Each room's shape gives strings different possible vibrations, and those vibrations show up as different physical laws in the larger world. In one folded shape, electrons may have a certain mass. In another, they may be heavier or lighter. Thus, the hidden geometry decides the visible physics. This leads to a quiet but powerful idea for the multiverse. If the hidden dimensions can be folded in many different ways, and if different patches of space choose different foldings as they cool and settle, then each patch could show different laws of nature. Some patches might have chemistry that works like ours, others might be so strange that stars never form, and still others could be hospitable in ways we cannot imagine. String theory, together with ideas about how regions of space choose different arrangements, suggests a broad landscape of possible universes, each with its own music of vibrating strings. String theory also introduces the idea of brains, a gentle but important image. Brains are like vast sheets or membranes that can stretch across higher dimensional space. Imagine a sheet of paper floating in a larger room. Life could play out on the sheet, and to those on it, the sheet would seem to be their whole world. If many such sheets float in a higher space, each could be a universe in its own right. Our universe might be one brain, and another brain could be nearby in the higher dimensional room. Sometimes these brains could move and even collide, and such collisions have been suggested as a possible cause for events like a Big Bang in some models. The collision would be a dramatic but quiet in our telling, meeting of two vast sheets, creating heat and matter where they touch. Another calm point is about gravity. In our everyday life, gravity is the weak force that keeps us on the ground and binds planets into orbits. But compared to the forces inside atoms, gravity is unusually weak. One gentle way string theory helps explain this is by suggesting that gravity might spread into the extra dimensions a little bit, while the other forces stay anchored to our brain. If gravity leaks into hidden directions, it would appear diluted to beings living on the brain, explaining its relative weakness. This is a soft, elegant idea that links geometry to strength in a way that feels like a natural consequence of a larger stage. Throughout these pictures, one theme returns. What we see may be only a small slice of what is. Hidden directions, folded shapes, vibrating threads, and floating sheets all suggest that beneath familiar appearances there could be a complex, elegant structure. If true, then the multiverse could be made not only of separate bubbles, but of many different folded geometries and brains, each carrying its own song. At the same time, string theory comes with a calm humility. It is an ambitious idea with deep mathematical beauty, but connecting it to experiment is hard. The strings are so small that directly plucking one is beyond our current technology. Many of the consequences live at energies much higher than anything we can make in a lab. Still, the theory has inspired new ways of thinking about space and matter, and it has suggested possible signs we might look for. Tiny deviations or subtle patterns that could point us toward hidden dimensions or brain dynamics. Researchers remain patient, like careful gardeners waiting for a season, testing what can be tested and refining the ideas where they can. A gentle story helps hold these images. Imagine a quiet city of musicians, each living inside a different concert hall with its own acoustics. The shape of each hall changes how the same set of instruments sounds. In one hall, a violin sings bright and long. In another, it sounds soft and round. Now imagine the halls are part of a larger hidden building of curved corridors and secret rooms. Those hidden spaces change the music without most listeners noticing why. String theory asks us to consider that our universe's music may come from hidden halls and secret folds, and that other universes might sing very different songs because their halls are shaped otherwise. As we finish this chapter, notice how the idea of higher dimensions and vibrating threads expands the ways we can picture parallel existence. It gives a new vocabulary for thinking about why laws of physics have the values they do, and it suggests mechanisms for generating diversity across many universes. Whether the true world uses strings and brains, or whether a different picture holds, the gentle lesson remains. Deep down, reality may be richer than the 3 dimensions we walk through, and exploring that richness enlarges our sense of possibility. In the next chapter, we will ask an important and practical question. How could we possibly find evidence for any of these ideas? We will listen to the subtle signals scientists search for, and the difficulties they face in turning grand pictures into testable facts. For now, let the image of tiny strings vibrating in hidden rooms settle, like a soft tune you can hum beneath your breath. Chapter 10. Evidence or Imagination. Searching for proof. Tonight we sit with a quiet, careful question. How would we know if any of these many universe ideas are true? Some of the pictures we have painted are lovely and poetic. Others come from solid math that explains things we already see. But moving from a good story to a proven fact requires gentle, patient work. In this chapter, we will trace the quiet path from idea to evidence, listen to the ways scientists look for hints, and hold the limits of what we can know with steady curiosity. Science is a careful craft. To trust an idea, researchers try to find signs it would leave behind. Small marks in the things we measure. For ideas about other universes, the marks are often tiny and indirect. One of the kindest examples is the soft glow left over from the universe's infancy. That faint light fills all of space like an old photograph, and it carries tiny patterns that tell a story about how matter was spread out when the universe was young. If something dramatic happened to our patch of space, like a collision with another bubble universe long ago, that event might have nudged that early light in a way we could see as a faint ring or a slightly odd pattern. Scientists look at the afterglow with careful eyes and ask whether any small marks match what a collision would make. Another place to look is the way galaxies and large structures are arranged across space. If the seeds of structure were planted by a process like inflation, then the pattern of those seeds should match what the theory predicts. Scientists compare the expected patterns to the maps of galaxies and the afterglow to see how well they line up. When the predictions match observations, confidence grows that the basic story is on the right track. But matching one theory does not prove all the consequences that theory suggests. A theory can explain some facts while also inviting broader pictures that remain out of reach. There are also ideas about waves in the fabric of space and time itself. If early events were violent or if brains collided, those events might have shaken space-time and sent out tiny ripples that still move through the universe. We can listen for such ripples with delicate instruments. If a specific kind of ripple were found, it might point to particular models of the early universe. But detecting those ripples is difficult. They are faint, buried under other signals, and require long, careful listening. Finding a clear ripple that only one idea predicts would be like hearing a single, clear bell in a crowded hall, a sign that opens a door. Not all multiverse ideas are equally open to these kinds of tests. Some versions suggest variations that might leave traces in the light we see or in the patterns of matter. Others propose realms forever separated from us by space that expands faster than any signal can cross. For those forever closed realms, direct evidence is impossible. They are beyond any light or message we could ever receive. That is the heart of the gentle worry many scientists voice. If an idea can never, even in principle, be checked by observation, is it a scientific idea or a metaphysical story? This is not a matter of taking joy from mystery. It is a practical question about how we build reliable knowledge. A calm reply is that even when direct evidence is impossible, related ideas may still be testable. If a theory predicts both a multiverse and some feature we can measure here, then confirming the measurable feature makes the larger idea more plausible. It is like testing whether a baker uses a certain recipe by tasting the cake they bring. Even if you cannot watch the baker in the kitchen, the cake's flavour gives a clue. Still, caution is needed. Finding a feature that matches one theory does not rule out other explanations, and scientists must weigh alternative possibilities carefully. Another soft challenge is the meaning of probability. Many multiverse ideas use probability to make sense of why our universe has friendly conditions for life. The thought is that among many varied regions, we find ourselves in one that can host observers. That reasoning is subtle because it skillfully mixes what exists with what we can observe. It can feel sensible, and it can feel unsatisfying. Some scientists find it a helpful way to think about why constants have the values they do. Others worry it becomes a tidy excuse that avoids deeper explanation. The debate is slow and polite, and it pushes physicists to sharpen their language and methods. Philosophy and science meet here in a gentle conversation. Some philosophers ask whether a theory that cannot be tested should get the same status as a theory that can. Some scientists answer that models which grow from tested theories deserve attention, even if not all of their consequences are reachable. This balance keeps the field honest. Bold ideas are welcome, but they must be treated clearly and their limits stated plainly. One comforting point is that our tools keep improving. Telescopes see farther, detectors grow more sensitive, and new techniques let us pull faint signals out of noisy data. Over time, ideas that once seemed purely speculative can move toward testable status. Still, even with improved instruments, some questions will remain stubborn. The horizon set by the speed of light and the history of the universe is a firm boundary. Some parts of reality may be closed to causal contact forever, and when that is the case, evidence for them must take indirect forms or remain separate from science. A small story can help us hold the situation gently. Imagine an island far from shore. Sailors can see its shape in certain lights, but cannot land because storms always rise. They can study the waves, feel the swell, and note how birds fly in and out. From those hints, they build a good picture of the island's cliffs and shores, but they still cannot walk its beaches. That is the position we sometimes find with the multiverse. We can study the waves and the birds, the traces and the indirect effects, but some beaches may never be walked. There is also the possibility that new, surprising signals may appear, things we didn't predict but that point us toward a larger picture. Science often moves this way, An unexpected measurement forces a rethinking that leads to deeper insight. If such a surprise were found, it could open doors we did not know were there. That is part of the excitement and the patience of research. It asks us to stay curious without being hasty, and to remember that good evidence builds slowly from repeated checks and careful reasoning. As we consider these issues, it is helpful to remember that even if some aspects of the multiverse remain forever beyond proof, exploring them enriches science and the mind. The act of crafting clear models, thinking about what could be measured, and arguing calmly about evidence refines our tools. It teaches humility about the reach of our senses and courage about the size of our questions. The multiverse debate is, in a way, a practice in thinking big while keeping our feet on solid ground. Before we move on to the next chapter, a small promise to keep you watching. Later we will explore how these cosmic ideas touch the most personal questions about consciousness, identity, and whether you might exist in other worlds. Those chapters will gently bring the vast down to the human scale, and they will include a thought experiment that many find both moving and peaceful. If you feel comfortable, let that thought sit like a pillow to look forward to. For now, breathe slowly and hold the image of patient researchers at their instruments, people who listen for faint bells and study subtle patterns. They remind us that knowledge grows not by leaps alone, but by many small, careful steps. The search for proof of the multiverse is one of those careful paths. It may lead to direct signs, or it may teach us how to ask better questions. Either way, the journey expands how we think about the world and our place within it. Chapter 11: Time, Infinity, and Possibility. Tonight, let us lean gently into something we feel every moment, but often understand the least: time. Time is the soft thread that strings our memories and our hopes together. It is the reason we can say before and after, the reason a story can have a beginning, a middle, and an end. As we move slowly through this chapter, we will sketch calm pictures of how time might work, how infinity shapes the meaning of moments, and how possibility and repetition weave together to make the world feel both broad and intimate. A simple way to start is with two quiet images. The first is a river flowing downstream. Leaves float on its surface, and each leaf moves from one place to another in a single direction. That is the common sense of time. Things change, and change has a direction. The second image is a book laid open on a table. The pages show events that happened earlier in the story, and pages yet to be read. Some thinkers picture time like that book. All pages are there, past and future alike, and the feeling of now is simply the page we happen to be reading. These two images, river and book, capture two ways people talk about time. Neither picture is complete on its own, but both help us hold the idea gently. One of the most important facts about time is that it seems to flow in one direction. A dropped glass breaks into pieces. Those pieces do not leap back together into a whole glass. Coffee cools. It does not warm up by itself. The reason for this one-way feeling has to do with a quantity called entropy. Entropy is a measure of disorder, or the number of ways something can be arranged. In most systems, entropy tends to increase with time. This simple tendency gives time its arrow, the sense that the past is different from the future. The early universe started in a very low entropy state, quite ordered, and since then entropy has grown. That slow, steady growth is what lets us remember the past but not the future, and what lets cause lead to effect in a comfortable, reliable way. Now, imagine time as a branching tree rather than a single river. At certain moments, choices might lead to different branches. If the many worlds view is correct, each quantum event that has multiple outcomes sprouts new branches, each with its own future. In that image, the past up to the branch is shared, but beyond the fork, each branch traces its own future. That transforms time from a single line into a wide living network of possible futures. The book metaphor changes too. Instead of one book, there is a library of books, each book a different unfolding of events. The branches are all real in that view, but each remains separate and self-consistent. Thinking of all possible futures leads us gently into the idea of possibility. What does it mean to say something could have happened differently? On one hand, possibility is a mental space where we play out alternatives. On the other, some theories propose that those alternatives are not just thoughts, but real paths somewhere in the larger fabric of reality. This raises a calming but deep question. Does every possible past or future exist somewhere? Some answers say yes. If the universe is infinitely large, or if many worlds is true, or if every mathematical structure exists, then many possibilities become actual somewhere. Other answers are more reserved. They say possibilities are just tools we use to think, not things that truly exist. Infinity plays a quiet but crucial role in these conversations. If space and time stretch without end, then many strange but simple results follow. Repetition becomes likely. Very rarely, even unique configurations might reappear. If time is infinite, events could recur in cycles or through rare fluctuations. Those ideas lead to quiet paradoxes and gentle puzzles. For instance, infinite time can make unlikely things happen simply by the virtue of endless opportunity. That is why infinity must be handled carefully. It widens possibility, but also challenges our usual ways of assigning meaning. A small, soothing story may help. Imagine a grand theatre that plays every night. If the theatre runs forever, and the playwrights try all melodies of stories, then the same play could be performed many times. Some nights the lines change only slightly, other nights the whole plot shifts. For an actor on stage in one performance, that night is unique and deeply real. Yet if you step back and count all performances across endless time, repetition becomes part of the pattern. The actor's experience in one night does not lose meaning just because another night had a similar script. The point is that infinity can make repeats likely, but it cannot take away the value of each lived moment. Another common thread concerns the idea of the present. Many of us feel that the now is especially real, that the present moment holds a kind of intensity or truth that past and future lack. Some philosophers call this presentism. Others, called eternalists, think that past, present and future are equally real. The difference is only in our perspective. Both views have a soft logic behind them. Presentism comforts because it preserves the feeling that life is lived moment by moment. Eternalism expands our view and offers a picture where every moment exists timelessly in a larger four-dimensional tapestry. For our gentle purposes tonight, both pictures can live side by side as useful ways to think about time. We can honor the vividness of the present, while also imagining a broader tapestry where many moments already exist. We should also touch on a quiet cosmic idea, the possibility that time itself could be different in other universes. In some worlds, time might pass faster or slower, or the rules that link cause and effect might vary. If so, then the sense of past, present and future might be very foreign to us. That thought opens a window to humility. Our experience of time is shaped by the particular way our universe cooled and unfolded. Other patches or other branches might tell very different temporal stories. Before we close this chapter, let us consider what all this means for how we live. If many futures exist somewhere, does that make choice less meaningful? Number. Even in a branching picture, your choices shape the branch you live in. The relationships you build, the love you give, the care you take, those are real here. Infinity and possibility can expand wonder and do not need to drain purpose. They can free us from a narrow view and invite gratitude for the fragile beautiful now. As you settle deeper into the quiet of the night, picture time as both river and library, flowing and still, immediate and vast. Hold the feeling that your present moment is a lantern you pass from second to second, a small warm light that matters. The cosmos may be wide and time may contain many paths, but this breath, this thought, this gentle attention is yours alone. Chapter 12: Consciousness and Parallel Selves. Tonight we sit very quietly with the most familiar thing we know and the hardest thing we can explain: the feeling of being you. Consciousness is the soft light that lets the world arrive as sight, sound, memory, and thought. It is where joys glow and where worries ebb. In this chapter, we will move slowly through calm, careful ideas about whether consciousness could stretch across many worlds, whether a copy of you is really you, and what it might mean for memory, identity, and the idea of a soul. We will keep the language plain and the pace unhurried, because these questions deserve gentle attention rather than hurried answers. First, let us notice what we mean by being you. At a simple level, it means a stream of experience. You wake, you remember, you feel, you decide. You have a history, a chain of events, relationships, and choices that make you who you are in the present. That story is held in a particular body and brain shaped by biology, upbringing, and the small accidents of life. When we ask whether another version of you could exist, we must ask whether we mean a physical copy, the same atoms arranged the same way, or whether we mean the living flow of memories and choices that make your life feel continuous. In the branching picture from quantum theory, versions of you in different branches share a common past up to the point where the branches split. They have the same memories and the same habits at that fork. After the split, small differences can grow into noticeable changes. From the inside, each version feels like a continuous person because each experiences a single thread of events. The peaceful way to hold this is to say that copies can be very similar up to a point, and then each life becomes its own river, flowing with its own currents. The people in those rivers are not less real because there are others like them. They are just distinct centers of experience. A simple thought experiment helps make the feeling clear. Imagine a quiet workshop where a skilled sculptor makes two statues from the same mold. At first, the two figures look identical. If the sculptor then gives slightly different textures to each, one gets a smooth finish, the other a gentle patina. The statues become distinct. They started the same, but small differences make them unique. Consciousness may be similar. Duplicates can be almost identical at one time, yet the tiniest change in experience can send them along different paths. Some people worry that if perfect copies exist, identity becomes meaningless. But meaning is not only a matter of pattern, it grows from relationships, actions, and the way others respond to us. Two people who look the same are still different in the way they relate and the people who love them. Even if far-off copies of you exist, your story here, the friends you have, the places you know, the small choices that shaped you, remain singular and meaningful. The existence of an alternate you does not erase the value of the life you live now. Another calm question is whether consciousness could somehow be shared across branches. Could one single self inhabit many versions at once? Most scientific views are cautious here. Consciousness, as far as we can tell, seems tied to physical processes in the brain. If the brain splits into two different physical histories, each set of processes would give rise to its own stream of experience. That suggests separate parallel consciousnesses rather than a single mind spread thin. Imagine a river splitting into two streams. Each stream carries water, but each has its own flow and sound. The two do not make one experience. They make two experiences that began in the same place. Still, there are gentle philosophical positions that imagine consciousness as less tied to a single physical seat. Some traditions think of mind as more like a field or a kind of pattern that could, in theory, exist in more than one place. These ideas are old and found in many cultures. They're comforting to some because they allow continuity beyond physical copying, and they place identity in a broader context that includes memory, moral qualities, and the sense of sacredness we sometimes call the soul. Others see these views as metaphors rather than scientific claims. Both approaches can be held respectfully in a calm exploration. Science traces what is measurable, while philosophy and spirituality explore meanings that matter deeply to people. An everyday, modern puzzle that touches this idea is teleportation. Imagine a machine that reads every detail of your body and brain, then builds an exact copy somewhere else, while destroying the original. Would the copy be you? Some say yes. Identity follows the pattern, not the particular atoms. Others say no, because your continuous experience would have been broken when the original was destroyed. This debate shows how tricky the idea of personal continuity is. In branching universes, the morning you and the evening you are connected by a continuous thread of experience. A copy created by a machine is a different case because it may break that continuity in a way our normal lives do not. Memory plays a special role in identity. If another version of you has the same memories up to a point, they will feel like they are you in many ways. Memory provides a narrative that links past to present. But memory is also fallible. Tiny differences in input or small random events can cause memories to diverge over time. Hence, even when two beings share an early past, the quiet accumulation of tiny experiences will shape two distinct persons. That gentle truth helps preserve the importance of the life you're living now. Your memories are being made here, and they carry weight. The idea of a soul is often brought into these conversations. Many faiths and philosophies hold that a soul is a timeless, indivisible essence that survives bodily change. If such an essence exists, then questions about copies and branches take on different meanings. Would the same soul inhabit multiple bodies? Might it travel between branches? These are deep spiritual or philosophical questions rather than scientific ones. For people who hold a soul view, the possibility of parallel selves can be folded into long-standing beliefs about continuity, moral growth, and ultimate meaning. For others, the soul is a poetic way of speaking about the cohesive patterns of a life. Both perspectives deserve gentle respect in a conversation about what it means to be someone. There are ethical questions too. If many versions of events exist, does that change our responsibility? The soft and steady answer is no. Responsibility remains local. The consequences of your choices affect people around you in this branch. You cannot rely on some far-off version of yourself to repair what happens here. Ethics asks us to relate to the beings we encounter and to act with care, not to imagine escapes in parallel lives. The possibility of many worlds can enrich our moral imagination by showing the many ways things could unfold, but it does not remove the need to act kindly now. A gentle story to cradle these ideas. A pair of twin lamplighters tend two long streets at dusk. For a while, their paths are the same. Each lamp they light throws warmth onto a similar patch of pavement. But after a few turns, each twin meets different passers-by, hears different small tales, and opens different doors. Their work remains meaningful because in each street the light touches people who need it. The fact that two paths began alike does not make either less real. In the same way, parallel selves do not reduce the value of the life you tend here. Before we close, let us touch on a comforting thought. The possibility of other versions of you can invite reflection rather than worry. It can prompt small, gentle questions. What choices matter most? What habits do you want to carry forward? How do you want to treat the people near you? Thinking about alternate lives can deepen gratitude for this one. It can also inspire us to live with more care, knowing that meaning grows from the attention we give to the present. In the next chapter, we will follow one of those threads more closely. We will ask what free will looks like in a world where many possibilities are realized somewhere, and whether that picture changes how we find purpose. For now, let your breath slow and hold this quiet image. Many paths might exist, but your steps here are uniquely yours. The light you carry matters to those who walk beside you. Chapter 13. Free Will in a Multiverse. Tonight we sit with a question that touches the place we feel most alive. Do we truly make choices, or is everything already written? The idea of many worlds changes how we ask this question, but it does not have to steal the feeling that our choices matter. In this chapter, we will walk slowly through what free will means, how different scientific pictures affect it, and why your sense of purpose can remain real, even in a vast and branching reality. First, let us name what people usually mean by free will. For many, it is the feeling that when you decide to do something, you could have done otherwise. It is the experience of choosing between options and feeling that your choice is your own. That feeling connects to responsibility, to praise and blame, to plans and promises. Even simple acts like offering a hand or saying sorry come from a sense that you could act differently if you chose. Science sometimes frames the issue differently. If the laws of physics are strict and everything follows inevitably from what came before, then in one sense the future is fixed by the past. That view is called determinism. But determinism does not always mean our choices are useless. Many philosophers and scientists take a middle way called compatibilism. Compatibilists say that even if events follow laws, our choices are part of that causal chain in a way that makes them meaningful. If your desire, your reasoning, and your values lead you to act, then the action belongs to you, even if physics describes how it happened. In this view, free will is less about being outside cause and more about being the kind of being that forms reasons and acts on them. Now, imagine a multiverse where every possible choice happens in some branch. One version of the story is the many-worlds picture, where each quantum-level possibility becomes real in its own branch. Does that make choice meaningless? Not necessarily. Consider a fork in a road. If at a crossroads many paths spread out, and some versions of you go one way while others go another, it can still be true that the version of you who chose a path did so for reasons. Within each branch, choices still connect to motives and consequences. The fact that other branches contain other choices does not erase the fact that here and now you had reasons and acted on them. In other words, making a choice still feels like making a difference for the branch you live in. A softer way to see this is to separate two questions. The first asks about metaphysics. Does some larger structure contain all possible choices? The second asks about agency. Do you experience choice and act responsibly? Many Worlds addresses the first by expanding what exists. It does not automatically answer the second. For your day-to-day life, the second question is what matters. When you promise, the people near you rely on the promise in this branch. The consequences of your actions play out here. Responsibility and meaning are grounded in relationships and outcomes in the world you share with others. Another gentle idea to keep in mind is probability and weight. In many worlds, not all branches are equal in a technical sense. Some branches carry more weight. They're like thicker threads in the weave of reality. Those weights line up with the probabilities we're used to. So when you choose between two options that have different chances of occurring, the more likely ones correspond to heavier branches. That mathematical fact helps make sense of why some choices feel more probable, while still allowing alternatives in other branches. It is a way of saying that even in a branching world, there is a kind of sense in which some outcomes matter more to the structure of reality. Let us take a small, simple example. Imagine you're deciding whether to call a friend tonight. If you call, you might cheer them up. If you do not, they might go to bed worried. In a branching picture, both actions might be realized in different branches, but in the branch where you call, your action made a real difference to that person. Your love and care mattered. The presence of a branch where you did not call does not erase the help you gave in this one. For ethics and responsibility, the path you take here shapes the lives you touch. There are other ways the multiverse can prompt reflection on choice. If many versions of you exist, some people feel less burdened by the fear of making mistakes. They may feel freer to explore, learn, and grow, knowing that many possibilities are played out somewhere. For others, the idea can feel disorienting. If many outcomes happen, what reason do I have to try? The calm reply is that our motives are local. You care about what happens to people you love here, and your efforts change outcomes in this branch. Trying matters because it shapes the world you already occupy, making it kinder or more beautiful for those in it. Some philosophers suggest focusing on what we can control, the quality of our decisions, the care we take, and the honesty with which we meet the world. Whether or not every possible outcome exists elsewhere, the practice of choosing well improves the branch we live in. It builds trust, deepens relationships, and creates meaning that does not evaporate into other branches. In that sense, free will becomes a kind of craft, a skill of living with attention and responsibility. There is also a gentle look at regret. If other branches contain versions of you who did things differently, can that comfort you? For some, the idea of parallel selves who made different choices can soften the sting of regret, because it suggests you are part of a larger family of possibilities. For others, it may make regret sharper, because it reminds them of paths not taken. Neither response is wrong. The calming way forward is to accept regret as a teacher while using it to shape better choices now. The existence of other branches can be a mirror that helps you see what you value most. We can also think about meaning. Some worry that if all possibilities happen somewhere, life's narrative becomes shallow. But meaning often comes from connection, growth, and values, not from exclusivity. A life lived with kindness, curiosity, and care has meaning in the way it impacts others and in the way it shapes the person you become. Whether or not some other version of you lives differently, your growth here is real and matters to those who share your world. A small story helps make these ideas gentle. There was once a potter who made many bowls. Each bowl looked similar at first, but the potter paid attention to small details. A steady hand, a careful turn, a thoughtful glaze. Some bowls cracked, some held water perfectly, and some were given as gifts that made people smile for years. The potter knew that making a good bowl required care. Even if other potters made similar bowls elsewhere, the way this bowl touched a table in this home mattered. In the same way, your careful choices shape the bowls you give to life here. Finally, let us consider hope. If the multiverse suggests many outcomes, it also suggests many chances. That thought can be hopeful without being reckless. Change remains possible in the branch you live in. Small steps, repeated kindly, can transform life and the lives of others. Your intentions, compassion, and steadiness remain the forces that shape the future you will live and share. As we close this chapter, let the soft truth settle. The existence of many worlds does not remove the meaning of your choices. It complicates the picture, yes, but it also deepens it. Freedom can be understood as the ability to form reasons, to care for others, and to act. Those capacities are real in this life. Whether or not other versions of you exist, the path you choose here, the kindness you offer, the work you do, the love you give, makes a difference that matters to those who walk beside you. Chapter 14. The Multiverse in Culture and Storytelling. Tonight, we settle into a softer place where science and story meet. People have always used tales to hold big ideas in a form our hearts can feel. The multiverse is no different. It is an idea that lives not only in equations and papers, but in films, books, plays, and the quiet stories we tell one another. In this chapter, we'll take a calm walk through how artists and storytellers have brought the multiverse to life, and why those stories matter to us in ways that are emotional as much as intellectual. Stories are how we try out ideas before we believe them. A movie can let us meet a version of ourselves who made a different choice, and through that meeting we learn about regret, hope, and what we value. A book can follow two lives side by side and show how a small decision grows into a very different destiny. These narrative tools do something science often cannot. They let us feel the human side of a vast abstract idea. When writers use the multiverse, they give us a way to test feelings, to imagine healing, or to see the weight of a single choice in a clearer light. Consider a film where a person slips between many lives and must hold together memory and love across different worlds. The emotion comes not from the novelty of the idea, but from the small, familiar things. A hand held in the dark, a letter read aloud, a song that brings two people back to the same tear. When a story uses the multiverse to focus on relationships, it becomes a way to ask, what matters most? Is it the single life you live, or the pattern of love you leave behind? These are the questions that make such films soft and powerful at once. Some popular stories present the multiverse with wild humor and big action. Others make it tender and strange. A film that uses multiple realities to explore memory and regret can leave you feeling both melancholy and oddly comforted, as if seeing many paths helps you forgive a single one. A TV show that jumps between worlds can use the contrast to laugh and to frighten, but also to show how resilient identity can be when tested. In books, poets and novelists often use parallel lives to explore moral dilemmas and the fragile thread of who we are. When the multiverse appears in popular culture, it often does so with familiar motifs: mirrors, hallways, doors, and reflections. These are simple images because they're easy to feel. A mirror shows another face. A door suggests a choice. Stories use these images to help viewers imagine a larger possibility without needing deep physics. That simplicity is a gift. It lets us carry the idea into the small acts of daily life. How would you speak to someone if you could see all the ways they might have become who they are? Art also helps us practice emotions we might not otherwise try. Imagine meeting an alternate version of a loved one who made different choices. A story can let us practice forgiveness, compassion, or curiosity. It can show that differences in life paths do not always erase the core of a person. In that way, the multiverse becomes a tool for growing empathy. We see how small accidents matter, and how, even in wildly different lives, people share deep, human threads. Another part of culture's role is to make the big idea feel less cold. Scientific talk about probabilities and constants can sound distant. A film or a novel translates these terms into faces and rooms, into heartbreak and joy. When a story shows a tiny decision echoing across worlds, we start to understand why some scientists are drawn to the multiverse in the first place. It offers a new way to frame meaning. But culture also keeps us honest. By dramatizing the emotional consequences, artists remind us that an idea is not just an intellectual toy, it affects how we imagine ourselves and others. At the same time, storytellers sometimes simplify the science to make the drama clearer. They may suggest that you can easily hop between worlds or talk to your alternate self. In real physics, these moves are usually impossible or highly speculative. Yet the simplifications serve a purpose. They let us explore deep questions in a form our minds can hold. Good stories use those liberties with care, giving us a mirror that helps us see our values without claiming to be an accurate map of the cosmos. There is also a playful side to cultural treatments of the multiverse. Comedy often takes the idea and stretches it into absurdity. Endless versions of a character, each about one slightly different joke. The absurdity can be liberating. It frees us from the fear that one misstep ruins everything, and it can invite lightness into otherwise heavy thoughts. That balance between solemn reflection and playful release is one reason the multiverse theme stays fresh in art. Another quiet role of culture is to bring ancient ideas into modern phrasing. Long before scientists wrote equations, poets and philosophers imagined many worlds in spiritual terms. Today's stories sometimes echo those old images, blending them with new scientific language. This weaving makes the multiverse feel both modern and timeless. It shows that our need to imagine beyond our horizon is not a recent whim, but a long human habit. A story helps us face the personal question, what if I met another me? It lets us practice the conversation we might never have, to ask whether we would praise or pity that person, whether we would learn from them or pity ourselves. The answer often reveals what we most value: honesty, courage, tenderness, or the simple act of paying attention. A good story uses the multiverse to bring these values into sharper, kinder light. As we close this chapter, notice a few small, steady thoughts that culture gives us. First, stories help us feel the human meaning of large ideas. Second, art translates cold numbers into warm moments. And third, narrative lets us test emotions and practice compassion in ways science cannot. If you feel drawn to see how fiction and film handle the multiverse, remember to look for stories that use the idea to deepen characters rather than merely to dazzle with novelty. Those are the tales that warm the heart and keep your attention until the last scene. To help you stay with the whole journey tonight, I will promise a gentle reward soon. In the next chapter, we'll imagine a tender, quiet encounter with an alternate self, a thought experiment that many people find moving. It will be slow, respectful, and designed to stir empathy rather than panic. If you keep listening, that scene will arrive and offer a small mirror for reflection. For now, settle back and feel how stories have guided us to understand the multiverse not just as a theory, but as a way to practice being kinder and more curious. Chapter 15. What if you could see another you? Tonight, let us drift into one of the most intimate and haunting questions that the multiverse brings to life. What if you could see another version of yourself? Somewhere out there, among infinite worlds and endless possibilities, there may be a person who carries your name, your face, your memories, but who made a single choice differently. Perhaps they stayed in a relationship you left, pursued a dream you abandoned, or took a path you were too afraid to try. Tonight we will explore what that meeting might feel like, what it could teach us about who we are, and why such a thought can both comfort and challenge us. Imagine for a moment that you're standing in a quiet room. The light is soft and the air feels still. Across from you stands another you, not a stranger, but familiar in every way. Their eyes are your eyes, only shaped by slightly different experiences. Their voice carries the same rhythm, but the words come with a tone that is foreign, perhaps calmer, perhaps sadder, perhaps filled with more joy. The silence between you feels alive, charged with all the moments that could have been. What would you say? What would you ask? And maybe more deeply, what would you feel? The idea of meeting an alternate self fascinates us because it brings the vast concept of the multiverse down to a deeply human scale. It turns cosmic theory into a mirror for the soul. It asks us not just what other worlds might exist, but what other versions of us could have become in one branch of reality. Perhaps you are living in another city, doing work that fulfills a dream you once had. In another, maybe you never met someone who changed your life here. Each version carries a different weight of happiness, regret, love, and loss. To see another you is to confront the truth that identity is not a fixed point, but a fluid river that flows differently with every choice. You might look at this other self and realize that you're not as limited as you think. There are infinite versions of your potential scattered across creation, all expressions of what you could have been, each one shaped by chance, by timing, by courage or fear. In a strange way, this can be freeing. It means that no single version of you holds the entire story. Each is just a chapter in an infinite book, written by the laws of physics, by probability, and by the quiet will of consciousness itself. But what would that encounter feel like emotionally? Would you envy them? Would you pity them? Or would you simply feel tenderness for a being who has carried the same burdens you have, only with slightly different outcomes? If you saw the version of you who made every right decision, would you long for their life? Or would you feel proud of the lessons you learned in yours? And if you met a version of you who made mistakes you avoided, would you judge them? Or see yourself reflected in their struggle? There's a beautiful symmetry in this idea, that every alternate self is both teacher and student. You might see in them what you have lost sight of, a spark of hope, a forgotten passion, or a version of innocence you thought had faded. In return, they might see in you the resilience they never found, or the wisdom that came only through failure. Each would remind the other that even across realities, the core of being human, the yearning to understand, to love, to grow, remains unchanged. Let's take a slow, simple story to bring this to life. Imagine a woman named Elise. In one universe, she chose to stay in her hometown, working quietly at a library, surrounded by the scent of old books and the comfort of familiar faces. In another, she left everything behind to chase her dream of becoming a painter in a distant city. One evening, through a strange twist of cosmic energy, these two versions of Elise see each other, just for a moment, through what feels like a thin veil of time. The librarian Elise looks at the artist with awe, her hair flecked with paint, her eyes glowing with a kind of freedom she once imagined. The artist, in turn, looks back and feels a sudden pang of peace, seeing the calmness and stability she secretly craves. In that instant, they both understand something profound. Neither path is better. Each one holds something precious the other lacks. The artist's fire and the librarian's peace are both expressions of the same soul, lived under different stars. Then, just as quietly, the vision fades, leaving behind a soft understanding that no matter the path, they were both complete in their own way. The story of Elise reminds us that our lives are not measured by comparison. They are shaped by the meaning we give to the paths we walk. The existence of another you does not make your life smaller. It expands it. It suggests that your choices matter not because they are perfect, but because they are real. Every act of courage, every mistake, every love and loss, all of it becomes part of a greater whole, a tapestry woven through the fabric of many worlds. There's also a quiet philosophical question that lingers. If you met another you, would you feel like the same person, Or would you sense the distance between two consciousnesses that diverged long ago? Some thinkers suggest that each version of you is a completely separate being, born from the same seed but growing into a distinct tree. Others imagine that all versions share a kind of spiritual connection, like echoes in a vast canyon of existence. Whichever you choose to believe, both ideas hold a quiet comfort. Either your individuality is vast or your essence is eternal. Now imagine the practical side of this encounter. What would you say to another you if given 5 minutes? Would you give advice or ask for it? Would you offer forgiveness or seek it? Would you embrace, recognizing that you both tried your best in different circumstances? These questions do not have fixed answers, but exploring them helps us understand ourselves more deeply. They remind us that the line between who we are and who we might have been is fragile, and that empathy, even for another version of yourself, is a powerful form of wisdom. Perhaps the greatest gift of this thought experiment is the way it helps us see our current life more clearly. If you could meet a version of yourself who made different choices, you might realize that even if everything had gone differently, some parts of you, your kindness, your curiosity, your desire to love and to be loved, would remain the same. The surface details change, but the essence persists. This realization can soften regret and bring peace to the parts of yourself that wonder, what if? You can even use this as a gentle meditation. Close your eyes for a moment, breathe slowly, and imagine walking through a doorway. On the other side is another version of you. Look into their eyes. Notice what is similar, what is different. Ask what they have learned. Thank them for carrying the weight of choices you didn't make, and before you leave, tell them that you understand, that in every version of life you are doing your best to grow, to learn, and to love. Then step back into your world, carrying that quiet understanding with you. In this way, the idea of meeting another you becomes not a fantasy, but a lesson in acceptance. It reminds us that we are all complex, ever-changing beings, that no single choice defines us forever. Somewhere, another you might be learning a lesson that you have yet to face. Somewhere else, you might be finding peace that you will one day reach. And in this moment, right here, you are part of that grand continuum, a living, breathing point in the infinite story of existence. As the stars move silently above, let that thought settle into you, that you are many yet one, that you are finite yet part of infinity. The multiverse may hold countless versions of you, but none will ever experience this moment, this breath, this heartbeat, this quiet awareness, exactly as you do. This is your thread in the fabric of eternity, and it shines in its own way, as it was always meant to. Chapter 16. The Meaning of the Multiverse. Hey guys, tonight we begin with a soft and honest question. If the universe is not alone, if many worlds exist in one way or another, what does that say about meaning? Does the picture make life feel smaller, or does it open a wider room for wonder? In this chapter, we'll move slowly through those questions, using calm language and quiet examples. We will keep our feet on the ground even as our imagination stretches outward, because meaning is something we live, not something only philosophers debate. First, let us name the worry plainly. Many people hear multiverse and feel a small chill. If every possible choice is made somewhere, does my choice here matter? If space contains copies of us, is my life less special? Those are fair feelings. They come from a place of caring about value and purpose. The gentle answer is that the existence of many worlds does not erase the value of the life you hold here. Meaning is woven from relationships, efforts, and the particular chain of consequences that unfold in this moment. Even if similar events play out elsewhere, your acts affect real people in this branch. Your kindness changes lives here. Your decisions shape the world you touch. That alone keeps meaning alive and real. A second way to think about meaning is to see it as a quality that arises from story and attention. Humans create meaning by telling stories about their lives, by naming what matters, and by building communities that share values. Suppose there are many similar stories across the multiverse. Each story is still told and still received. A story becomes significant not because it is unique in the space of all possible stories, but because it is lived, remembered, and woven into other people's lives. The person you help, the child you teach, the song you write. Those things create ripples here. Ripples matter in the pond where you stand. Another helpful idea is to separate metaphysical facts from practical life. The metaphysical question asks what exists out there in the wider sense. The practical question asks how to live well given what we know. Even if the metaphysical answer includes many worlds, the practical task remains. How do we live with care, curiosity, and compassion? The multiverse can be read not as a threat but as an invitation to deepen ethics and widen empathy. If many lives are possible, the one you live becomes an even richer opportunity to practice goodness, not a reason to shrink away. The multiverse can also expand wonder. For some, knowing the cosmos might contain many kinds of worlds is humbling in a beautiful way. It makes our tiny planet feel both fragile and precious. The thought that the laws of physics could take many forms invites gratitude that conditions here allow life to arise at all. It invites awe at the delicate balance that lets galaxies form, planets cool, and life begin. In that sense, the multiverse can be a prompt to celebrate the rare and fragile gift of being alive where we are. Philosophically, people respond in different ways. Some find comfort in the idea that many possibilities exist because they feel less worried about missed chances. If another version of them lives differently, it can soften regret. Others find the thought jarring because it highlights paths not taken. Both responses are human and useful. They reveal what we value. The gentle practice here is to use those responses to learn, not to avoid. Let regret teach you which future you would prefer, and compassion guide how you act toward others now. Another part of meaning concerns creativity and curiosity. The multiverse is a rich source of metaphors and stories. Artists, writers, and musicians borrow its images to explore identity, loss, and joy. Those works help us understand our own lives more deeply. When a film shows alternate selves, it does not tell us facts about the cosmos so much as it gives us a safe space to feel complicated truths, grief, longing, the relief of forgiveness. Art transforms big, cold ideas into warm, human moments. That is kind of meaning-making that the multiverse actually enhances. There are also moral lessons we can draw. If our actions are multiplied in theory, then the best response is to be mindful of the effects we do control. Practice kindness because people in this branch will benefit. Work for justice because the outcomes here matter to real lives. The existence of many worlds should not be an excuse for moral quietism. Rather, it can motivate us to imagine a greater reach for our values, reminding us that what we do here helps shape experience for people who are real to us. Turning to science, the multiverse invites humility and curiosity. It reminds scientists that some questions may be forever beyond direct observation, and that recognizing limits is part of good science. At the same time, it opens new lines of inquiry, new searches for subtle signs, and new ways of framing why constants have the values they do. The practice of science, careful testing, rigorous debate, patient measurement, becomes itself an expression of meaning, the work of understanding reality more clearly step by careful step. That work nurtures a collective human purpose, the shared effort to know a little more tomorrow than we did today. Many people also fold the multiverse into spiritual frameworks. Some traditions find it easy to include many worlds in ideas about souls, karma, or cosmic cycles. Others prefer to keep spiritual meaning independent of speculative cosmology. Both approaches can coexist with respect. Spirituality often answers why questions about meaning in ways science does not attempt to. The multiverse does not invalidate spiritual insights. It can simply add a wider canvas on which those insights are painted. A practical habit that helps carry meaning in the face of large ideas is gratitude. Gratitude focuses attention on what you have and on the people you love. It is a gentle discipline that can steady the heart when thoughts grow large and abstract. Similarly, practicing presence, paying attention to the small details of today, anchors life in the here and now. These practices do not depend on metaphysical certainty. They work whether the cosmos is one or many. Finally, there is a soft, poetic truth we can hold. Meaning is not found solely in uniqueness, but in depth. Even if you are not the only being to ever feel joy or sorrow, the way you carry those feelings, the acts you perform, the care you give, the beauty you create, can be deep and singular. A song sung once in a quiet kitchen can change a life. A hand held in a hospital room can lighten fear. Those moments are not diminished by possibilities elsewhere. They are luminous because they are lived here. As this chapter closes, let your breath slow and bring your attention inward. The multiverse is a vast idea, but the place to practice meaning is right here, in your choices, in your kindness, and in the way you bring presence to the people around you. Let wonder and humility sit together in your chest. Let curiosity drive you to learn more, and let compassion keep your feet steady. In the next chapter, we will move gently into practical reflections and small exercises for living with the wonder and the questions we've explored. Little practices that help you carry this vastness without losing calm. For now, rest with the idea that brilliance and tenderness can live side by side, that your life matters where it is lived, and that meaning grows from what you give and how you attend